Okay, pre-cal, this hopefully will be your last topic 2, Unit 7 video. So I'm going to jump back in here and continue with your examples for your trigonometric proofs. All right, so on number 7, we have tangent theta plus cotangent theta, and we need it to equal cosecant theta times secant theta. So the easiest thing to do here, since I need cosecant and secant, those are reciprocals of sine and cosine, so I'm going to rewrite tangent and cotangent using my quotient identities. So tangent theta, if you'll recall from your identity sheet, I'm not going to revisit it right now because we've done that a lot. I can rewrite it this way. Cotangent I can rewrite as this, and this, of course, these are the quotient identities. All right, so the next thing I can do, and now I've got two fractions, so I need to get an LCD. So I'm going to get a common denominator of LCD, and it's going to be cosine theta sine theta. So, of course, I've got to multiply this side by cosine theta over cosine theta because the denominator's missing the cosine. And over here, I've got to multiply the numerator and denominator by sine theta. All right, so once I do that, I end up with sine squared theta plus cosine squared theta over sine theta cosine theta. And then, of course, if you'll recall from your identity sheet again, I can replace sine squared theta plus cosine squared theta with a 1. And that, of course, is one of my Pythagorean theorem identities. And then if I break this apart, I have this. That's just an expansion. And then 1 over sine is actually cosecant theta. And 1 over cosine is secant theta. And we are exactly where we need to be. And of course, the reciprocal identity allows me to do that. Okay, so let's look at number 8. If you can see this here, we've got tangent theta plus cotangent theta squared. So I want to expand that and then FOIL it. So I've got tangent x plus cotangent, theta, not x. So I'm going to expand this. So that's an expand. And then I'm going to FOIL it. Dang it. I'm out of control. Can't take me anywhere. Y'all are like, we know, Miss Griggs. We've met you. And of course, I ran out of room again. That's awesome. Okay, this one's going to be tricky. So I'm just giving you a heads up. On our identity sheet, I need to remind you of something. We don't use these reciprocal identities very much, this top row, but man, they can be handy. Anytime you've got cotangent theta times tangent theta or tangent theta times cotangent theta, you can replace it with 1. And that's what we're going to do right here and right here. So I end up with tangent squared theta plus 1 plus cotangent squared theta. And why was I able to do that? Because of my reciprocal identities. Awesome. So now what I'm going to do, if you'll notice this is squared and this is squared, I want you to revisit your identities sheet again and look at your Pythagorean triples. I want you to notice, this is beautiful, you're going to love it. 1 plus cotangent can be replaced with cosecant squared. 1 plus cotangent squared, and 1 plus tangent squared can be replaced with secant squared. What? I know. It's totally amazing. So this tangent squared theta plus 1 can be replaced with secant squared theta, and 1 plus cotangent squared theta can be replaced with cosecant squared theta, and that's what we need. See, look at that. That one's kind of hard. Sorry, babies. All right, beautiful. All right, as we move through here, number 9 is tricky, just like number 8 was. So on number 9, you need a helpful tip here, because if you'll notice the denominator 1 minus sine x, if that was 1 minus sine squared x, that would be helpful, because our Pythagorean theorem identities would help us rewrite that, but it is not squared. So since 1 minus sine x, we can't do anything with that, we need to multiply by its conjugate. Miss Griggs, what's a conjugate? Well, we've already talked about conjugates, but it just means this right here. Okay, you just change the sign. That's your conjugate. So I'm going to take cosine squared x over 1 minus sine x, and I am going to multiply both the numerator and the denominator by the conjugate. You have to multiply the numerator and the denominator. And remember, we're trying to get here. So I'm multiplying my numerator and my denominator, so I'm going to rewrite this okay, when you FOIL these, okay, remember when you have negative and positive, that middle term, that negative sine x and positive sine x, when you FOIL, it adds to nothing. So you end up with a difference of squares here, and that is what we want. So all I did here, multiply by the conjugate, that's all I did. And then I ended up with this right down here. Notice that I want to end up with 1 minus sine x, and I have it right here. So that means if I can find a way to reduce cosine squared x with 1 minus sine squared x, that would be really helpful. Well, if you'll recall from your identities page, again, I know that 1 minus sine squared theta equals cosine squared theta. So that is going to help us. So I am going to replace that with cosine squared x. And of course, that is just my Pythagorean theorem identity. And then I just reduce. And I have exactly what I need. This video is getting too long. Okay, so let's hurry up through number 10. I want all of this to look like this. I know it looks like a stretch. So we've got two fractions added together. We have to get an LCD. So that is my very first step. I'm going to get an LCD. Obviously, it's going to consist of 1 minus cosine x and 1 plus cosine x. So I am just going to rewrite this and then multiply both sides by what's missing. All right, so I end up with 1 plus cosine x plus 1 minus cosine x, because when I multiply that by 1 and multiply that by 1, that's what I get. And then, of course, in my denominator, I end up with 1 minus cosine x times 1 plus cosine x. All right, so in the numerator, I'm going to combine like terms. 1 plus 1 is 2, and those add to 0. And then, of course, I need 2 cosecant squared x. So I'm going to have to do something with that denominator. It's not looking good, okay? So I found my LCD. I multiplied through right here. That's that step. And then, of course, I combined like terms. Groovy. All right, and then I'm going to FOIL this, so I end up with 1 minus cosine squared x. And remember, a Pythagorean theorem identity will enable me to change this to sine squared x. And then, of course, I know that I'm going to bring this over here. I know that 2 over 1 times 1 over sine squared x, that's just an expanse right there, so I expanded. And then I've got, I can replace this because of my reciprocal identities with cosecant squared x, reciprocal identity, and then that's exactly what I need. Bam!